Welcome to Space Nexus. Please subscribe and hit the bell icon for more breaking updates. Imagine a tiny metallic emissary, smaller than a school bus, hurtling through the cosmic dark. This is Voyager 2, our silent ambassador to the stars. For nearly half a century, it has journeyed outward, past worlds of swirling gas and icy moons, toward the great unknown. Now, from a distance so vast that its whispers take almost a full day to reach us, it is sending back secrets from the very edge of our solar system. These are not just numbers on a screen. They are revelations that challenge our understanding of our place in the universe. The journey of Voyager 2 is a testament to human curiosity, ingenuity, and our unyielding desire to know what lies beyond the next horizon. When we launched this probe in 1977, we were casting a message in a bottle into the cosmic ocean. Today, as it navigates the turbulent boundary between our sun's influence and the vast expanse of interstellar space, it is answering questions we once thought unanswerable. Its discoveries about a wall of fire and strange magnetic fields are not just for scientists. They belong to everyone who has ever looked up at the night sky and wondered, what's out there? The data streaming back from over 13 billion miles away forces us to confront the true scale of our cosmic neighborhood. By studying the edge of this bubble, Voyager 2 is essentially examining the walls of our cosmic home. The final chapter of the Voyager saga is being written right now, one faint signal at a time. The story of Voyager begins in a different era, a time of bold ambition and cosmic alignment. In the late 1970s, scientists at NASA realized that the giant outer planets, Jupiter, Saturn, Uranus, and Neptune, were about to enter a rare alignment. This celestial syzygy offered a unique opportunity. A single spacecraft could use the gravity of each planet to slingshot itself to the next, completing a grand tour. Thus, the Voyager program was born. Two identical probes, Voyager 1 and Voyager 2, were built to seize this moment. Launched just weeks apart in the summer of 1977, their primary mission was slated to last only 5 years, focusing on Jupiter and Saturn. Voyager 2's journey was nothing short of spectacular. It remains the only spacecraft in history to have visited all 4 of the gas and ice giants. At Jupiter, it discovered new moons and witnessed volcanic eruptions on Io. At Saturn, it studied the intricate rings and the thick, hazy atmosphere of Titan. Then, it ventured into uncharted territory, giving us our first close-up views of Uranus and Neptune, and revealing active nitrogen geysers on Neptune's moon Triton. After its final planetary flyby of Neptune in 1989, Voyager 2's cameras were switched off forever to conserve power for a new, even more ambitious objective, the Voyager Interstellar mission. For decades after leaving Neptune behind, Voyager 2 sailed through the vast, empty expanse of the outer solar system. As of today, in late 2025, Voyager 2 is over 13 billion miles from Earth. Communicating with the probe across this cosmic chasm is an exercise in extreme patience. A command takes over 19 hours to reach Voyager 2, and another 19 to hear back. The signals themselves are incredibly faint, with a power of less than a billionth of a watt by the time they reach Earth. The probe's longevity is powered by its 3 radioisotope thermoelectric generators, but their power output decreases each year. To keep the mission alive, NASA engineers have had to make difficult choices, shutting down non-essential systems and even some science instruments. In October 2023, the plasma science instrument was turned off. In March 2024, the low-energy charged particle instrument followed. Each shutdown is like saying a final goodbye to an old friend, but each sacrifice buys precious time, potentially allowing at least one instrument to continue sending back data into the 2030s. The long, lonely voyage is becoming quieter, but it is not over. Voyager 2 continues to push onward, a silent sentinel reporting from the darkness. Every faint signal is a triumph of endurance and ingenuity. The primary goal of Voyager's interstellar mission was to reach and cross the heliopause, the theoretical edge of our solar system. On November 5, 2018, after 41 years, Voyager 2 crossed the Great Divide. Its instruments detected a sharp drop in solar particles and a jump in galactic cosmic rays, the telltale sign it had entered interstellar space. It became only the second human-made object in history to do so, following Voyager 1. The fact that 2 spacecraft crossed this boundary at different locations confirmed the heliosphere is not a perfect sphere, but a dynamic, fluctuating bubble. Voyager 2's passage provided a smoother, more defined crossing, giving scientists a clearer picture of the boundary structure. Crossing this frontier was more than just a milestone, it was the beginning of a new era of discovery. For the first time we had a direct line of data from the other side. Voyager 2 was now looking back at our solar neighborhood from the outside, providing a perspective once reserved for science fiction. One of the most startling discoveries from the edge of the solar system is the confirmation of a so-called wall of fire. As Voyager 2 crossed the heliopause, its instruments registered plasma temperatures soaring to between 30,000 and 50,000 Kelvin, several times hotter than the surface of our sun. This intense heat is created as the solar wind abruptly slows down when it collides with the dense, cold interstellar medium, converting kinetic energy into thermal energy. The plasma at the heliopause is incredibly tenuous, so despite the high temperature, the probes pass through unscathed. This confirmation is profoundly important. It gives us a direct measurement of the physical process at the very edge of our sun's influence. The interaction between our solar system and the galaxy isn't gentle, but a violent and energetic collision. This wall of fire is the front line in a constant battle between the solar wind and the interstellar wind. Understanding this dynamic helps scientists refine their models of how stars interact with their galactic environments. Beyond the shocking temperatures, Voyager 2 delivered another perplexing piece of the puzzle. As it crossed into interstellar space, its magnetometer sent back data on the magnetic field it encountered. Scientists expected a dramatic shift in magnetic field direction at the boundary, but Voyager 2 found the fields were surprisingly aligned. This suggests the interstellar magnetic field drapes smoothly over our solar bubble, rather than colliding at a sharp angle. Voyager 1 had reported a similar finding, but Voyager 2's confirmation means this is a large-scale feature. The standard model of the heliosphere's interaction with the galaxy did not predict this alignment, forcing scientists to rethink their theories. The value of having two probes is immense. It allows for confirmation and a more complete picture of this distant region. The universe is often more complex and surprising than we imagine, and Voyager 2 continues to be our guide. The Voyager probes were never designed to last forever, and now face an unavoidable challenge: dwindling power. Every year, the mission team at NASA's Jet Propulsion Laboratory has about 4 fewer watts to work with. To keep the mission going, they have embarked on a strategy of graceful degradation, systematically turning off instruments one by one. The goal is to conserve enough power to keep the most essential systems running, while allowing at least one science instrument to continue collecting data. Each instrument turned off is a scientific capability lost forever, but it is a sacrifice made in the name of longevity. The team's goal is to keep a single instrument on each spacecraft operating into the 2030s, squeezing every last drop of science from these explorers. The data that continues to trickle back is from a region no other spacecraft has ever reached. The slow fade of the Voyager probes is not a story of failure, but one of profound success. Why should we care about discoveries made billions of miles away? Because this research is fundamentally about us. The heliosphere, the very bubble Voyager 2 is now studying, shields us from high-energy galactic cosmic rays that can threaten life. By measuring the properties of this shield at its outermost boundary, we learn about its strength and vulnerabilities, crucial for future human exploration. The data from Voyager 2 helps us build better models to predict radiation exposure for astronauts and design safer spacecraft. Studying how our sun's heliosphere interacts with the galaxy also guides our search for habitable exoplanets. The Voyager mission has pushed the boundaries of engineering and communication, driving innovations that benefit us on Earth. Ultimately, the impact is also deeply social and philosophical, expanding our perspective and reminding us of our place in the cosmos. Knowing our silent ambassadors are out there fills us with wonder and a sense of shared purpose. As the Voyager probes continue their journey into the interstellar dark, their scientific mission will eventually come to an end. When their power finally fades, they will fall silent forever, but their journey will not be over. They will continue to coast through the Milky Way for millions of years, carrying with them a message from their creators. Each probe carries a golden record, a gold-plated copper disc containing sounds and images to portray the diversity of life and culture on Earth. The act of creating and sending the golden record was an act of profound hope, a statement about who we are and who we aspire to be. The legacy of Voyager is twofold: a legacy of incredible scientific discovery and a legacy of human aspiration. The probes themselves, along with their golden records, are our silent ambassadors, They represent the very best of the human spirit, our drive to explore, to learn, and to reach beyond our grasp. So the next time you look up at the night sky, reflect on the fact that two tiny, human-made objects are out there, farther than any have gone before. They carry our music, our languages, and our image, a testament to what we can achieve when we work together and dare to explore the unknown. The story of Voyager urges us to keep looking up, to keep asking questions, and to never lose our sense of wonder.